account for the intensity of what the magnetometer recorded. Something in the vicinity of the probe was interacting with the magnetic environment. Something was generating field disturbances that Voyager 2's instruments were picking up from the outside. And when analysts mapped the direction from which those disturbances were propagating, the result was not a uniform ambient field, it was directional. It had a source that Voyager 2 was moving toward. The plasma density readings told the same story from a different angle. As reported in the analysis of the transmission data, Voyager 2 detected a sudden and significant jump in plasma density in the region immediately ahead of its trajectory. The interstellar medium does not produce density walls of that kind without a cause. Something was compressing the plasma in the probe's path. Something with mass, or with the ability to affect the electromagnetic environment, was sitting ahead of Voyager 2 on its trajectory through interstellar space. The probe's instruments were not malfunctioning. They were measuring something real. And the something real was not on any map, not predicted by any model, and not consistent with any natural body that should exist in that region of space. The response inside the scientific community was divided along a fault line that has always existed in conversations about the deep, unknown. One side argued for caution. The interstellar medium is poorly understood. Voyager 2's instruments are nearly 50 years old. Hardware degradation produces artifacts. Cosmic rays corrupt data. The anomalies, while striking, were within the range of things that might be explained by physics we have not yet fully characterized in that region of space. More data was needed. More analysis was required. Extraordinary claims require extraordinary evidence, and what the transmission showed was unusual, not impossible. That position is scientifically defensible. It is also exactly the position that gets taken when the alternative is too significant to process in real time. The other side of the divide pointed to what the data actually showed when taken as a whole. Not any single anomaly in isolation, the plasma pulse alone, or the magnetometer readings alone, or the density jump alone, but all of them together. A repeating, structured signal in the plasma waves, rapid directional magnetic field disturbances, a sharp increase in plasma density directly ahead of the probe's path, every instrument pointing at the same region of space, all at the same time, all registering something that the baseline interstellar environment should not be producing. The convergence of independent instrument readings on a single conclusion is not the signature of a hardware glitch. Hardware glitches do not coordinate across separate instrument systems. What was ahead of Voyager 2 was registering on every sensor the probe carried, and it was registering from a specific direction, not ambient, not uniform, directional, localized, present. What makes the timing of this discovery so difficult to dismiss is the parallel with Voyager 1. When researchers went back to the archived telemetry from Voyager 1's passage through a nearby region of interstellar space years earlier, they found something that had been filed as insignificant at the time. A brief data anomaly, a spike in the plasma readings, a momentary irregularity that was attributed to background interference and moved past. Running that archived data through modern analysis tools, the waveform that emerged matched the current Voyager 2 readings with a similarity that the probability of coincidence cannot comfortably explain. Both probes, different trajectories, different times. The same signature appearing in both data streams from the same general region of the interstellar medium. Either both spacecraft experienced identical hardware failures at the same location in space years. Apart, or something in that region of interstellar space produced the same effect on both of them. One of those explanations is far more disturbing than the other. Voyager 2's power source is dying. The radioisotope thermoelectric generators that have kept it running for nearly 5 decades lose approximately 4 watts of power per year. Instruments have already been shut down one by one to keep the most critical systems alive. The window through which we are reading what Voyager 2 is experiencing is closing, narrowing, aiding with every year that passes. What is ahead of the probe in Interstellar? It has been traveling for nearly 50 years, farther than any human-made object has ever gone, through the outer planets, past the last boundary of the sun's influence, and out into the cold interstellar dark where no mission was ever expected to reach, let alone survive. And now, from a distance of over 12 billion miles from Earth, Voyager 2 has sent something back that changed the atmosphere inside NASA's Jet Propulsion Laboratory the moment it was decoded. Not a routine science reading, not a telemetry update. Something else entirely. Something that confirmed a fear that certain scientists had been quietly carrying for years, but never said out loud. Because saying it out loud meant accepting a truth that rearranges everything we thought we understood about what is waiting for us in the space between stars. Voyager 2 launched on August 20th, 1977. It was never supposed to reach interstellar space. The mission was designed to last 4 years, swing past Jupiter and Saturn, gather what data it could, and drift into irrelevance. But the spacecraft refused to stop. It kept flying. past Uranus in 1986. The only close-up images of that planet humanity has ever seen came from Voyager 2, past Neptune in 1989. Still the only spacecraft in history to visit it. And then onward into the Heliosphere toward the Heliopause, the invisible boundary where the sun's solar wind finally loses its fight against the interstellar medium pressing inward from the rest of the galaxy. On November 5th, 2018, Voyager 2 crossed that boundary and became only the second human-made object to enter true interstellar space. The scientists monitoring the crossing celebrated. They should have been more careful about what they were celebrating entering into. For years after crossing the Heliopause, the data Voyager 2 sent back was strange but manageable. Plasma density higher than expected. Magnetic fields more structured than models predicted. Cosmic ray counts. In early 2025, engineers at NASA's Deep Space Network Receiving Station in Canberra, Australia, noticed something wrong with Voyager 2's signal. Not wrong in the way that aging hardware goes wrong. Not a degraded carrier wave. Not a power fluctuation from the dying plutonium source. Wrong in a different way. The signal contained data sequences that did not correspond to any command Voyager 2 had been given. The probe was transmitting information it had not been instructed to transmit, in patterns that its own programming should not have been capable of generating. When the raw data was cleaned up, filtered, and run through analysis, the structure that emerged from the noise was not what anyone in the room had prepared themselves to see. And if you're not already on the edge of your seat, hit like and subscribe, because what the data actually showed is the part that nobody at JPL could explain away. The transmission contained an oscillating pattern in the plasma wave readings that repeated with a precision that natural. Interstellar turbulence does not produce. Random fluctuations in the interstellar medium are exactly that, random. They do not repeat. They do not pulse at consistent intervals with consistent amplitude across multiple data passes. What Voyager 2 sent back pulsed with regularity. The same signature appearing again and again in the cleaned signal with a mathematical consistency that analysts described in internal reports as almost identical every time it appeared. Not environmental noise, not the kind of degraded hardware ghost signal that mission engineers had learned to expect from aging systems. A repeating sequence. The kind of repeating sequence that, when you rule out the natural explanations one by one, leaves you with a question that no official statement is designed to answer cleanly. The magnetometer data compounded the problem. As Voyager 2 moved deeper into the interstellar medium, its instruments registered rapid magnetic flux changes in the region around the probe. Sharp, sudden shifts in the local magnetic field that the surrounding environment should not have been capable of producing. The interstellar medium in that region is not dense enough, not energetic enough, and not structured in a way that could. Space, whatever it is that its instruments converged on in those transmissions, will not be reached in time for a fully functioning sensor suite to measure it. By the time Voyager 2 arrives at the coordinates that its readings pointed toward, it may be running on the minimum power needed to transmit anything at all. The final transmission may already be close. And the data in that final transmission, whatever it shows, may be the last direct measurement humanity takes of whatever is out there in the dark between stars, waiting in a region of space that was supposed to be empty. What Voyager 2 confirmed is not a comfortable thing to sit with. It is not the clean, reassuring message that science fiction imagines first contact looks like. It is not a signal decoded into mathematical greetings or universal constants. It is instrument readings, converging from multiple independent systems, pointing at something in interstellar space that does not fit the map. Something that produced the same anomalies in both Voyager probes years apart. Something that exists in a region that every model of the interstellar medium said should contain nothing capable of producing those readings. Whether it is an undiscovered structure of natural origin, a phenomenon of physics we have not yet written equations for, or something else entirely, that question remains open. But the fear that the transmission confirmed is simpler and older than any of those explanations. We sent two machines into the dark, and the dark sent something back. There's a detail in the transmission data that mission engineers flagged, but that received almost no attention outside of specialist circles. The repeating oscillation pattern in Voyager 2's plasma wave readings did not appear at random intervals during the data stream. It appeared specifically when the probe's high-gain antenna was oriented in a particular direction, the direction from which the magnetometer disturbances were also propagating. In other words, the structured signal in the plasma readings intensified precisely when Voyager 2's instruments were pointing toward the location of the anomalous density increase. This is not the behavior of a decaying sensor producing artifacts. A failing instrument generates noise regardless of antenna orientation. What Voyager 2 recorded was directional. It was registering something more strongly when it faced that something directly. The probe was not malfunctioning into a signal. It was detecting one. The Deep Space Network station in Canberra that received the transmission operates the only antenna in the southern hemisphere capable of maintaining contact with Voyager 2 at its current distance. The signal takes over 19 hours to reach Earth, traveling at the speed of light. By the time it arrives, whatever generated it is already 19 hours further into the past. Scientists reading Voyager 2's transmissions are always reading the recent history of a probe they cannot reach, cannot adjust in real time, and cannot redirect. If something is interacting with Voyager 2 in interstellar space right now, the first evidence of it will not arrive for 19 hours. The response from Earth will take another 19 hours to reach the probe. In that 38-hour window, Voyager 2 is entirely on its own, running on programming designed in the 1970s, with instruments built for a mission that was supposed to last 4 years. It has been out there for nearly 50, and whatever it has found in the dark, it found alone. Governments and space agencies choose their words carefully when data raises questions they are not yet prepared to answer. The language that surrounds Voyager 2's anomalous transmissions and official statements is the language of caution, of process, of appropriate scientific skepticism. Interesting anomalies, continued analysis, further data required. This is how science is supposed to sound. But between the lines of those careful statements is a reality that the measurements themselves make clear. The interstellar medium surrounding our solar system is not the featureless void that half a century of theory described. Something is out there, something that 2 probes independently detected, something that pulses with regularity, distorts magnetic fields, compresses plasma, and produces readings that no model predicted, and no natural explanation has yet fully satisfied. Whatever Voyager 2's final transmission eventually confirms, it has already confirmed this much. We were wrong about the emptiness of the dark. And being wrong about that means everything that was built on that assumption needs to be rebuilt from the beginning. Like and subscribe, because the next transmission from Voyager 2 could be the last one. And what it says when it finally arrives may answer the question we have been afraid to ask since the moment we first looked up at the night sky and wondered whether anything out there was looking back.